Okay, so for this, they say, assume that the weight of the babies born in the hospital are normal distributed, mean 3 kg, standard deviation 0.25. So write out your distribution first. X will be your weight of your babies. So X distributed normal, mean 3. So in distribution, we need variance. This one is 0.25 standard deviation. We will square to get variance. So for the first question, A, find the probability that still talking about weight, means talking about your X, in between 2.75, 3.2 kg. So we can denote it here. You can see your X here is start from normal. So what we need to do is change to standard form, z-score. Then we draw out the normal distribution. And then we find out from table to get answer. So this is the flow and the step for us to solve the normal distribution questions. So to find z-score, it will be minus mean over standard deviation. X will change to z. And then your z-score, we need only 2 decimal. In your table, just display 2 decimal. So you round off your z-score to 2 decimal. So this one will be negative 1, and then this one will be 0.8. So when we draw out this normal distribution, your region or your probability will fall in between negative 1 and 0.8. So in the middle here. So to get table, your table always right tail table, it will be 1 minus the left hand side tail and the right hand side tail. So 1 minus the reading of negative 1, we will read it as positive 1. And then at the same time, the reading of 0.8. So reading of 1, 0.1587, 0.8, 0.2119. So you simplify, you can get 0.6294. Then we proceed to question B. B is say 5 babies. So now you come to sampling. You have 5 babies chosen randomly. Find your probability at least one of them. So you are choosing your baby, it's not changing the weight already. So your distribution denoted here difference. So we start with Y will be the number of babies that in the situation has weight more than 3.25 kg. So what we need here is distributed binomial, sample with 5, probability with the weight more than 3.25 kg. So first of all, we need to find out the weight X more than 3.25 first. Alright, so change to Z minus mean over standard deviation. So it will be 1. Z-score 1 more than that, so we just read the table straight away, which is 0.1587. Then only your distribution complete with binomial sample 5, the situation with more than 3.25 kg is 0.1587. So from here, we need to find out at least one of them. Probability, the number of baby, at least more than equal one of them. So for this distribution binomial, we can't use table. We only can use formula. So if you calculate more than equal 1, it will be y equals to 1, 2, 3, 4, 5. So quite a lot of calculation. Or we can calculate 1 minus dy equals to 0. It will be more simple. So binomial formula n CR p power of r, which is 0, q, it will be 1 minus 0.1587, so it will become 0.8413. So 0.8413 will power n minus r, which is 5. So you will use your calculator, 0.5785. Then we can proceed. For question C. So for question C, if the baby with weights in the first quartile is considered small, so what is your maximum weight in this category? So it's talking about weight. So it's back to this normal distribution. So when you want to consider small, you want it to be first quartile, means 0.25. The probability for the weight that less than one value, so the maximum here less than W, it will be equal to 0.25. So first quartile means indicate 0.25 in probability. Maximum weight, so your weight will be less than W. W will be your maximum weight. So come back to this X when you're talking about weight. So it will start back with normal distribution. So means in this equation, it is in the status of normal. Then we change to Z. We draw the normal distribution graph and find from table to get answer. So to change to Z, this unknown maximum weight need to minus mean 3 over standard deviation 0.25. So where this is our unknown, let us denote this unknown to be A. Then when we want to draw out this normal distribution, you need to guess where's your z-score. Your z-score might be at left-hand side. If you're less than that, this area is 0.25. So this area value and this drawing is matching. If you're doing at right-hand side, less than that, this area is bigger than half. Then this value is not stand for that bigger than half. It must more than 0.5. Right? So your z-score that you don't know, it will fall on left-hand side. So based on this drawing, how we read from table means we're going to read the tail value of A to get 0.25. So look at your table for your last page, 0.25. So it has its corresponding z-score, 0.6745. So your A here, 0.6745, and because it is at left-hand side, means this value is supposed to be negative. Then we substitute back our unknown here, it will be the weight minus 3 over standard deviation. And we simplify the value W. So multiply back 0.25 and plus back 3, 2.83. So do we need to round off this value? Do we need to make it integers? No. So it will be remain in this decimal because of what? Because this is about your weight. Your weight is about your continuous random variable is in decimal. So no need to round off. Okay.